Here we go with homework number 2. So for our first conceptual question here, we have this graph to the right, and we see here that this y-axis is not labeled. And the question is, if this y-axis is position, does the object ever change direction? So what we're thinking about is changing directions really means changing the sign of our velocity. So on a position graph, if this is position, velocity is the slope. So we want to look for a time when the sign of the slope changes, going from going down to going up or vice versa. And we see right here, we're going down until we get to 5 seconds, and then we begin to go up. So at that point there, we do have a change in direction. So the answer would be yes at 5 seconds, because the sign of our velocity, also the sign of our slope, changes. Moving on to part B, we're now going to look at if this graph is velocity instead of position. And so once again, the same goal, we want to see if there's a time when we can change the sign of our velocity. And on a velocity graph, that occurs when we cross the velocity equals 0 line, which is the x-axis. So we're looking for times when it goes from above the x-axis to below, and that happens twice actually. Once at 2 seconds, going from positive to negative, and once at 8 seconds. So we have 2 changes in direction if this is a velocity graph, at 2 seconds and 8 seconds. For the next part, we have a series of graphs here, and we want to draw the matching graph, either velocity or position, depending on what we're given. So what I'm going to do first is I'm going to break up this first graph into 3 parts, and I'm really going to think about 2 things here. I'm going to think about whether we have a positive or negative velocity, and whether we have a positive, negative, or 0 acceleration. You also can think about whether you're speeding up or slowing down. That works as well, as we've done in some of the sorting problems in class. So for this first one, I have a positive velocity here because I have a positive slope, and I have 0 acceleration, meaning I'm traveling at a constant speed. So moving on to my velocity graph, that's going to just be a horizontal line. Then I go on to my next part, and I see that I have, for this next segment, I have a velocity of 0, an acceleration of 0. There's no slope here, so there's no velocity. So on my velocity graph, that means I'm going to drop down to the x-axis. And you can connect this. Technically, that's impossible, but that's what the position graph is showing. So we'll draw the appropriate velocity graph that matches it. For the last segment here, this curve piece here, I see it's a positive velocity because we're going up. It's also concave up, so we have a positive acceleration, which means we are speeding up. So I'm going to go over here, draw a positive velocity, which would be above the axis, and a positive acceleration, which means a positive slope. And I can verify that this is showing speeding up because we're going away from the axis, just like this is showing speeding up because we're getting slopier. Moving on to my next position graph, same thing here. I'm going to break this into a few segments. It actually looks like there's 4 segments here. So we'll start working through those one at a time. For this first curve here, what I see is I have a positive velocity because I'm going up, but a negative acceleration, and that matches because I'm slowing down here, getting flatter. So on my velocity graph, I'm going to start above the x-axis, but get closer to 0. And we actually do hit 0. We see that right at this point here. The graph completely flattens out, so it's okay to draw that to 0. Then looking at this next portion here, that little curve piece there, that's showing a negative velocity because we're going down, and a negative acceleration now because it's still concave down. So what that is going to be on the velocity graph is below the axis with a negative slope. So something like that continuing through. This point right here that I'm going to point out, same thing that's there, is very important. That is a point where we are changing directions. All right, so that's something that's going to be important to recognize. You don't necessarily need to label that, but that is something that's important to recognize. Looking at the next portion of the graph, this line here, we still have a negative velocity, but now there's no curve, so that is showing 0 acceleration. On my velocity graph, we're down here in negative land, but it's just going to be a flat line. No slope, no acceleration. And for this final bit, when we flatten out here, that's showing 0 velocity. So we're dropping back to 0 and just riding along that axis. Okay, moving on to our next two, we have some velocity graphs. So let's start with this first one, break it up into its parts, and think about the motion for each one. So this is showing a negative velocity here because we're below the axis, and 0 acceleration. So on my position graph, and I'm going to start up here somewhere because I know I'm initially going down. On my position graph, though, I'm going to show a straight line because of 0 acceleration with a negative slope, so something like that. Next, for this segment here, we still have negative velocity, but now we see that the line's approaching the x-axis, meaning it's slowing down, and it has a positive acceleration because it's going up. All right, so there's that slowing down. And so on my position graph, I want to continue drawing that line down because I still have a negative velocity, but I want it to be concave up. I also can think about how it's flattening out because we are slowing down. So continue going down, but flattening out, drawing that curve there, which sometimes can be a little tricky to draw. For that last part here, that last segment, I continue yet again to have a negative velocity, and now I have a negative acceleration. So we want to continue drawing our line down, but now it's going to be concave down, showing the object speeding up, and that's what our velocity graph shows. Going away from that x-axis, we are speeding up. And finally, for my last one, breaking into segments yet again, starting with a negative velocity because we're below the axis, a positive acceleration though, because we're slowing down and we have a positive slope. So on our position graph, we're going to start by going down. All right, so I'm going to start up here, going down but having a positive concave up, showing slowing down. All right, and we see that this is flattening out. We then cross the axis, which remember means we're changing directions, that point right there. And now we have a positive velocity and still a positive acceleration. So on my position graph, we're going to be going up and continue to be concave up, so something like that. And that's showing speeding up. And then this last portion here, still have a positive velocity because we're above the axis, but that line flattens out, no slope, no acceleration. Moving to my position graph, we're going to continue traveling up, but now it's going to be a straight line. You're going to end up sometimes with these kind of rough connection parts where there's like a little bit of a corner. I'm not going to nitpick about that. As long as you're trying to show the correct shape, that's the important piece. It is sometimes a little bit tricky to draw those curves perfectly, so don't worry too much about that. Alright, for this one, we're going to be drawing both a position graph and a velocity graph to match the motion shown in this strobe diagram here. We see that there are points A, B, C, and D labeled on our strobe diagram, so I'm going to make those same marks on both graphs to help me draw the graph. Alright, and then I'm going to think about the motion for each. So, for this part here, A, this is showing a positive velocity because we're going to the right, and it's also showing a constant velocity. So, on a position graph, positive constant velocity is going to be a straight line going up. On a velocity graph, it's going to be a horizontal line above the axis. For the next part, for B, what I see is still positive velocity, but a negative acceleration because we are slowing down. Okay, and so on the velocity graph, we're going to continue up, we're going to be concave down and flattening out as we slow down. On the velocity graph, that means we're still above the axis, but we have a negative slope going back to 0, showing us slowing down. For the next part, going to C, I see that we do two things. Number one, we change directions, so now we have a negative velocity, and I also see that we're speeding up, which means we also have a negative acceleration. One little thing to note and kind of keep in the back of your mind, and I'm not going to nitpick that much about this, but you should notice that by the time we get to C, we're traveling faster than the speed we had at A, and so our graph should indicate that. So we should have a greater slope on our position graph. So I'm going to go ahead and draw this here. So I'm going to draw a line curving down like that, negative velocity going down, negative acceleration, concave down, and speeding up. And on my position graph, I'm going to draw a line going down. And you notice I'm intentionally drawing it a little bit steeper and a little bit curvier, going back to that idea that this speed here at C is going to be greater. For the last part at D now, I see that we are traveling with a negative velocity going to the left, and now we have 0 acceleration because it's just a constant. So I'm going to draw the rest of my graph here. For my position graph, I'm going to draw a pretty steep line, and it's okay that I cross below the axis. That simply means that I went past 0 position, and I started from here. I started from that initial point, and so I went past it. Again, don't worry too much about that, but if we're being technically correct, this one should end up below where I started because I went further to the left here than where I initially started. On my velocity graph, it's going to be negative, and it's just going to flatten out, showing negative velocity and 0 acceleration. And again, this is a technicality, but I do notice that my velocity here was less than the value of my velocity here, because I am traveling faster from C to D than I was from the beginning to A. Moving on to the next one, we have a story here, and we need to do the same thing. So I'm going to once again go ahead and label my graphs with A, B, C, D, E to match up with the story. Alright, so for the first part, we have Alfalfa is walking to class at a steady speed in the positive direction. So on my position graph, that's going to mean a positive slope, and it's going to mean a straight line indicating a steady speed or 0 acceleration. On my velocity graph, above the axis, and a horizontal line showing that there's no acceleration. Slows down to a stop to check out his sweet cowlick in the mirror. So on my position graph, that means I'm going to now have a negative acceleration, still a positive velocity though, but I'm slowing to a stop. So concave down and really flattening out there, and there's my stopped point. On my velocity graph, it means still a positive velocity, so above the axis, but a negative slope. I'm showing my Alfalfa slowing down to a stop there at point B. C, he stays still a while looking at his cowlick. So on my position graph, that's showing 0 velocity, just a horizontal line, meaning 0 slope. On my velocity graph, I'm going to be right there along that axis, along that 0 velocity. And then D before speeding up again to a run. So now we're going to show speeding up, so positive velocity, positive acceleration, which means my position graph is going up and is concave up, and that shows speeding up, getting steeper or getting slopier. On my velocity graph, above the x-axis and a positive slope, going away from 0, showing speeding up. And then that last little bit, while walking through the door, his cowlick gets caught and slows him down to a stop yet again. So on my position graph, we now have a negative acceleration but still a positive velocity. So continuing up but concave down, showing slowing down to a stop. On my velocity graph, it means still above the x-axis but negative slope, showing slowing down all the way to a stop there at point E when it gets back to the axis. Alright, for this one we have a given motion, and we need to draw both the strobe diagram and the velocity and position graphs for this motion. So we have a ball initially at point A with a given velocity, and it's going to roll here up this ramp. We know it eventually comes to a stop, as we know a ball will. Roll back down and then along to C. So we're going to draw our dot diagram showing this. So I'm actually going to extend that first arrow to make it a little bit easier, because we clearly want to show it slowing down. So there's my first arrow. My second one getting a little bit smaller, going all the way up to the top here at B. Alright, and then it's going to roll back down. So I'm going to show it going in the other direction, and now it's going to be speeding up as it rolls down here to the level part. And then once we get to C, it's just going to be going at a constant speed. So I'm going to show nice, even velocity. Alright, so it should look something like that. The key is we're showing it slowing down, going up to the top, speeding back up as it rolls down, and then constant along that flat portion. Alright, so now we want to go ahead and draw a motion diagram showing this. Let's start with our position graph. Okay. So initially for that first part here, this segment, the ball is slowing down with a positive velocity, meaning it has a negative acceleration. I'm going to actually start my graph up here because I know that eventually I'm going to come back to the point where I started. So I'm going to show slowing down with a positive velocity, which means we're going up, but we're concave down. Something like that. On my velocity versus time graph, I'm going to start with the positive velocity, but go towards 0. That takes me to my first point. Then we're going to change directions and speed up for that next segment in the opposite direction, meaning we have a negative velocity and negative acceleration. Remember, this was positive velocity, negative acceleration. So for that next segment, I'm going to show concave down and negative velocity, so going down. On my velocity graph, it means I'm going to continue through into negative land and maintain that negative slope. And so we can see how both of these show speeding up, getting slopier in the case of the position graph, and going away from the axis in the case of the velocity graph. Then I hit this constant part here. That's my final segment, and I still have a negative velocity, but now I have 0 acceleration. So on my position graph, that means I'm just going to continue straight. On my velocity graph, that means I'm going to flatten out and maintain that velocity. Alright, so our final conceptual one here is we're given a velocity versus time graph, and we need to write a story that matches the given graph. And so what I'm going to do here is, obviously your story could be about almost anything, but I'm going to talk about what the motion looks like and the key elements. So initially, we look at this graph, look at this first segment here, and we see that that is showing 0 velocity and 0 acceleration. So from 0 to A, this object is stopped. Okay. Then we jump up here and we have a positive velocity, all right, and 0 acceleration, meaning constant. So from A to B, that is showing a constant positive velocity. This next segment here, from B to C, we still have a positive velocity. Now we have a negative acceleration. So B to C, you should discuss some motion that involves slowing down with a positive velocity. Okay. And then this final segment here from C to D, that is showing a negative velocity and a negative acceleration. So that would be speeding up with a negative velocity. So if you're looking for an example story, maybe you have a car that's sitting at a stoplight. For this first part, the light changes to green and the car instantly begins traveling at a constant speed of 20 miles an hour, we'll say. But then the driver realizes that he forgot something, and so he slams on the brakes, slowing to a stop here at C, throws the car in reverse, and begins speeding up in the opposite direction, which obviously would not be a good idea if you were actually driving, but that would be a story that could work. There's obviously lots of possibilities, but you need to have these motions included in your story.